Okay, this is Unit 9, some notes on Target 6 using the law of cosines. You can use the law of cosines anytime that you are not using the law of sines. Remember that we know when we can use the law of sines based on a triangle that we have. Doesn't matter what kind of triangle it is. But we use the law of sines when, for example, we have angle A as 120 degrees, and maybe then we have side A equal to 50. Whenever I have both of them, I can use the law of sines. We can use the law of cosines when we're looking at the information, angle A and side A, but something's missing. Like, for example, I only have angle A as 120 degrees, but I don't have side A. Or instead of that, I have side A was equal to 50, but I don't have angle A. The law of cosines is still based on the angle and the side across from it. We use the law of sines when we have both. We use the law of cosines when we have one and we want the other one. So here's the law of cosines formula. Now, I know that most teachers will set it up, and your geometry textbooks will set it up with a squared, a, b, and c. A, b, and c being the sides of your triangle, angle A, angle B, and angle C being the sides of or the angles of your triangle. Some teachers will also show you that there's three formulas, and really the formulas are the same formula. They're equivalent to each other. They're based on different information. I'm going to show you it, the same concept, just from a slightly different perspective. I have the x squared at the beginning in red, and I have cosine at x at the end. The x squared at the beginning and the cosine x at the end go to this idea of wanting to work with an angle and the side across from it. So the law of cosines formula starts and ends in the formula using an angle and the side across from it. Wrong button. So I made a note there. X squared at the beginning is the side opposite the angle that you have, or the angle that you want to have. Cosine x at the end is the angle opposite the side that you have or want to have. The y and z's in the middle, and your teachers may have used b squareds and c squareds or whatever, those are just the other two sides. I even said b and c down here. I should have changed that to y and z. So it doesn't matter. It's just the other two sides. So let's go through a problem. So find all the missing dimensions of triangle ABC, given that angle B is 98 degrees, side A is 13, and side C is 20. I can draw that out to get a visual for it. I can also realize that they said angle B is my angle, but there is no side B. So because the only angle I have is B, and they didn't give me the side across from it, I know that I have to use law of cosines instead of law of sines. Okay, so we do not have an angle and the side opposite, so we have to use law of cosines. I did go ahead and draw out the triangle. A lot of times drawing out a triangle might be easier for you to do the problem. We have angle B, so we're going to start with the side opposite and fill in the other two sides and the angle into the formula. You always begin the formula with the side opposite the angle you want to have, or the angle you have. So since I have this 98 degrees for angle B, I'm going to start my formula with b squared equals. Okay, the law of cosines starts with the side opposite the angle you have, and it ends with the angle you have, or the angle you're working with. So my formula is going to start with b squared. Again, the side I'm trying to find. It's going to end with cosine b. And then the other numbers in the middle are going to correspond to the other two sides. So 20 squared plus 13 squared comes from the 20 and the 13. The formula has a negative 2 times 20 times 13, again the other two sides. So I plugged in all the numbers. you can use your calculator to calculate everything on the right side of the equation. So I typed all that in my calculator, 20 squared plus 13 squared minus 2 times 20 times 13 times cosine 98 degrees, and I got 641. That 641 is equal to b squared. So we need to take the square root of both sides. Taking the square root of both sides gives me a b value of 25.3. So the law of cosine seems a little intimidating, but once you set it up and you're solving for a side length, it's pretty fast to work with. Now finding an angle is a different story, and we'll do that next. So same triangle, we have 25.3. We have a rule that says once you begin a problem with the law of cosines, you want to stay with the law of cosines. Later, when you see the ambiguous case for the law of sines, you'll find out why. If you switch to law of sines, you could create an issue where you have a second triangle that you're not really trying to work with. So stay with the law of cosines. At this point, I need to pick either angle A or angle C. Choose an angle to solve for and set up the law of cosines again. We'll use angle A, but you could do the same for angle C. So I set up the equation, this time using A as the numbers that I wanted. So angle A is the angle I want. Side A is the side I have. So I started with the 13 squared, and I ended the problem with cosine A. It's always based on the angle and the side opposite. The other information in the triangle is the other two sides, 25.3 and 20. I have a 20 squared and a 25.3 squared, minus 2 times 20 times 25.3. Now, this one's not as easy to work out to get the angle. You have to do a little bit of algebra, and you have to be specific with how you do it in the calculator. But it can be done as kind of a 2 or 3 step process over and over and over and over, and you can get very comfortable with it. First, we're going to start by simplifying the 13 squared and saying that is 169. Okay, I also made a little note. We set it up this way because the side A is 13, and it's opposite the angle we want to find. Reminder, you always start with the side opposite the angle you have or the angle you want to have. So we want to have cosine A, we want to have angle A, so we start with side A. So I did a little bit of simplifying. I put it in green there. 20 squared plus 25.3 squared is 1040.49. I also did the rest of it. 2 times 20 times 25.3 is equal in pink, negative 1012. And you can't subtract the green and pink numbers because the pink number, negative 1012, is actually part of a term attached to cosine A being multiplied. So now we solve with algebraic steps. How would we get rid of 1040.49 on both sides of the equation? We would subtract it. So we subtract 1040.49 on both sides. 169 minus 1040.49 is equal to negative 871.49. That's equal to negative 1012 times cosine A. So our next step would be to divide on both sides, because right now we are multiplying by the 1012 on the right. So cosine A is equal to this decimal, 0.8616. We have to do that inverse. Notice here that I did use the answer feature on the calculator instead of typing in a rounded decimal. If you're not going to use the answer feature, then you need to try to use like 5 or 6 decimal places so that you get the same rounded answer as us. And so we did all of that to find A. Inverse cosine of that decimal, A is 30.6 degrees. So I have 98 degrees, I have 30.6 degrees. We just have to find the third angle. We can do that by adding them up, subtracting from 180, or subtracting each one from 180 separately. C is 51.4 degrees, and that is an example of the law of cosines. I could go through the other examples, but this is already a pretty long video, so we're going to stop there, and you can go back and watch the law of cosines. Example 4 is going to be the same thing. It's actually done the exact same way as example 3. And then example 5 starts with 3 sides. So the difference for example 5, when you start with the 3 sides, is that you would pick an angle. I like to do A first because of alphabetical. Since I want to find angle A, I would start with side A. So 30 squared equals, and I would end it with a times cosine of A. The rest of it would be the other two numbers. So plus 15 squared plus 20 squared minus 2 times 15 times 20 times cosine A. And you would go from there, just like in the second part of the last example.